In today's video, I will solve the problem for the refrigeration system as we discussed in it previous video. So today I will be solving its problem. So this is the TS diagram and the layout of the problem. As you can see in the evaporator, the core region, the Q in is shown as its temperature is 0 Celsius or 273 Kelvin, which is also the temperature provided to the evaporator from the food items. So it boils it, the refrigerant in it, and it goes into the compressor. As you can see in the TS diagram, from the saturated vapor state, it goes to the superheated state. So we will find the enthalpies at both stages. The refrigerant which we are using in this problem is R134A. So this is the table of this refrigerant, as we have to find the first enthalpy at the temperature of 0 Celsius. As you can see in this table, the Hg is 247.23 and its entropy is 0.9190. So this is the enthalpy entropy for the first stage. Now to find the enthalpy of the second stage, we will see this TS diagram. As you can see, the 2s point, which means that it is isentropic process. So the temperature which it goes from 0 to 26. We will again go into the table. As you can see, at 26 Celsius, the pressure is 6.8530 bar. So the 2s point is actually the superheated stage. So the enthalpy at 26 Celsius is not the enthalpy of stage 2. We will only see the pressure line or the pressure point at 26 Celsius as it is superheated. So we will go into the superheated table and match the temperature and pressure lines. As you can see over here, the pressure is 0.70 megapascals and temperature of saturated is 26.72. Now this and exact the same temperature and pressure. We will choose the approximate value as it is given to 65.37. So at 30 degree we will use 264. As you can see, the 40 Celsius value is 275 though, so there is a difference of 3 or 4 between 1 degree. So we will use 264 value. We can find the exact value of the H2S point by also using the WES software, in which we will put the temperature and the pressure points. You can also see this software from my steam power plant video. The enthalpy of the stage 3 can easily be found by just going to the table A10 and going to the temperature of 26 degree and the HF value. As after condensation it is saturated liquid state, so we will just see the HF value as it is 85.75. As the last stage is throttling process, so the enthalpies will be same. H3 is equals to H4. Now as we have calculated all the enthalpies, now we will calculate the work done of the compressor. Now as you can see, work done of the compressor is equal to the WC by time, as is flowing at a certain time rate, is equals to mass flow rate of the fluid into the H2S minus H1. Now we put all three values and do the unit conversion. Here the WC by T is equals to 1.4 kilowatts. And now we will calculate the heat transfer rate to the refrigerant which is passing through the evaporator. So its formula is given as Q by T is equals to mass flow rate, which is M by T into H1 minus H4. So again we will put all three values and do the unit conversion, and Q by T came out as 3.67 tons. Now finally we will calculate the coefficient of performance which is denoted by beta. It is equal to Q dot in by WC, so which is equal to H1 minus H4 divided by H2S minus H1. We put all four values, and the coefficient of performance came out as 9.24. So this was pretty easy to solve the problem of the refrigerant cycle. Now in the next video I will tell you the improvements of the refrigerator cycle. So like, share, and subscribe my channel for more videos. So that's it for today. Thank you so much. Khuda Hafiz.